Welcome students to this video lesson. Today our learning objective is to be able to write an algebraic proof using theorems and deductive reasonings to find a solution. So within this, as you can see, we're going to talk about some algebra. So we'll have a little bit of Algebra 1 review, but we'll also be talking about theorems and deductive reasoning. And what that really gets at is proofs. And this is the heart of geometry right here. So by the end of the lesson, hopefully you are able to complete this two-column proof. Okay, so like I said, it's really just going to be an algebra lesson today with a couple extra rules thrown into it. So why don't I have you start with this algebra review problem. Hopefully you are able to look at this and say, yep, I know how to solve for x. So take a moment, pause the video, and solve for x. Okay, hopefully you were able to get the solution x equals 4. If not, you might want to double check your algebra. But here's where I'm going to introduce what we're actually doing today with the algebra skills. So first, you're looking at the problem and you go, well, I'm going to add 13 to both sides. If I add 13 to both sides, I end up getting 2x equals 8. Well, I know if I'm solving for x, I want x by itself, so I'm going to divide both sides by 2, and I get x equals 4. Okay. So hopefully that wasn't too hard. What I actually did is, in a two-column proof, I performed what are called the statements. The two columns, there's the statements and the reasons. The statements are the part of that's actually the math. Okay, this is what you actually did. The reasons is the thought process that goes behind it. Okay, now there's a couple of rules when it comes to filling out this reasons column. The first rule, always, 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 is given. Okay, you are just given a problem. Okay, you don't have to think about it all, you just write the problem down. So number one thing is always, always, always given. Now this is where it starts to get a little tricky. What you want to do when you get to the next reason is you don't want to just look at statement 2. You want to actually look at statement 1 and how did that become statement 2? Well, we said that what we did is we added 13 to both sides. So what we did is we did addition. So again, I'm thinking to myself, how did I go from 1 to 2? That reason goes across from it at 2. So we're going to use the same process here for step 3. Instead of step 3, I'm just like, oh, x equals 4, I'm done, right? I'm not going to write done for my reason. I'm going to write, what did I do from step 2 to step 3? How did I get x equals 4? Again, we said we divided by 2, so we did division. Okay, so this is your building blocks for a two-column proof. They're going to get a little harder as we go, but we're just going to start easing into it with using our Algebra 1 knowledge. So if you look at your guided notes, you have a really long list of things that you have to fill in. These are the algebraic properties, and they're pretty straightforward, but we have to write them down just in case. So if we have anything that's equal, like A equals B or whatever, right? So this equals this. What you can do, the golden rule of math, is whatever you do to one side, you have to do the other. So the addition property of equality is simply you can add something to both sides. Okay? We actually did that back here. Oh, it was hidden. We added 13 to both sides. We did the addition property. Now we should probably write addition property of equality. That's really long, so I'm going to let you off the hook today and say you should just write addition property. Okay. Next, the subtraction property is pretty self-explanatory as well. If you have an equality, you can subtract the same thing from both sides. Again, I'm just using letters here to abbreviate the idea of what you do to one side, you must do the other. Okay, so I'll go pretty quickly through the other two. Multiplication, you just multiply both sides by the same thing. Division, you can divide both sides by the same thing. Again, we did this property as well when we went from 2x equals 8 to x equals 4. Now you'll just know the little caveat here that c can't be 0 because, of course, you can't divide by 0. Now there's some other properties on here that aren't as obvious. There's something called the reflexive property, and I'll show you in a little bit how you would use this. But the reflexive property means something equals itself. Pretty self-explanatory, right? Well, I just like to think of this one as a reflexive, like you look in the mirror and you see yourself back. So the reflexive property, you equal yourself. The symmetric property is that you can change things around from, say, the right side to the left side, and it doesn't change the value. So for instance, if I said 2 squared equals 4, well then 4 equals 2 squared. The transitive property and the substitution property are kind of like the same idea. Transitive, I like to think of this one as like a train. So if you have one end connected to the middle and the middle connected to the other end, well then really they're all connected to each other. So the first and the last things are equal to each other. So that's a transitive property. Substitution, kind of the same idea. Substitution, you know from algebra, you can replace one thing with another thing of equivalent value. So it's kind of what we did in the transitive property up here. We took out B and we replaced C. And finally, the distributive property is just an algebraic property you've probably done for a while now. When you have a number outside of parentheses, you need to distribute it in. So hopefully these definitions make sense, but let's try using it in another proof so we can see how it would play out in action. So like I said, we're mainly doing algebraic proofs, but the second day we work on algebraic proofs, we're going to introduce some geometry. So here's a little forward step for you. What I'm given is my problem. So what I know is that angle ABC is congruent, that's the congruent sign, to CBD. I know CBD is 50 degrees, and I know CBE is 100. What they'd like me to prove is that ABC, this guy right here, is congruent to DBC. So the two outer ends are congruent to each other. Okay? So if we go back to our understanding of proofs, we know that the first thing is just the problem. Statement number 1 is always just what is given to us. Okay? We were given this problem with this picture. Okay. Now we didn't know this before in the algebraic proofs, but we are actually given what we're trying to prove. And that is simply that ABC, well this is not liking me here, is congruent to DBE. You're always going to end with the final step. So before in the algebraic proof it was x equals whatever number. Here they told us what we're trying to prove, so that's the last step. So really we barely have any blanks left now. And you know what? You know another blank too. The first reason is just the problem, right? So they gave us the problem, so we were given it. Okay, let's keep going. So we need to see the picture on this one up here. Okay, number 2. So remember, if we're looking at reason 2, this is going to help me get from statement 1 to statement 2. The reason is right here. Now I know we don't know what the angle addition postulate is, so I'm going to help us out on this one. CBE. What the angle addition postulate is that you can add a couple angles and get the angle that it makes up. So, like I said, I'm kind of giving you this one. If I take angle CBD and add it to angle DBE, well, yeah, of course I'm going to get CBE. If you want to try it with numbers, that might make more sense. Say this is 30 degrees, you add another 30. Of course, you're going to get the larger angle, which of course would be 60. So that's just giving a name to it, which we'll learn about in another lesson coming up soon. Okay, so let's keep going. What we need to do is we need to fill out reason 3, given this statement. So again, I'm not just going to read this statement and be like, oh, where'd they get that from? What I'm going to do is I'm going to say, how did 2 become 3? Well, so if I notice, the DBE is still in the DBE spot. But instead of angle CBD, I have 50 degrees. Why did they do that? Well, if I go back up to my given, CBD is 50. So I took out CBD and I plugged in 50. Well, plugging in, I have a much better word for that, and that's just substitution. I've demonstrated the substitution property here, which we just wrote down on the previous page of our guided notes. I substituted CBE and put 100 in place of it as well. So I can do more than one substitution at a time. So because they're the same rule, I can write substitution property together on the same step. Okay, so now let's use our algebra skills here. How did I get from step 3 to step 4? What changed? Well, I noticed this 50 degrees is gone. but the 100 became a 50. How did they do that? Well, hopefully, from the previous example, you can see that they subtracted 50 from both sides. So like this is one of those instances in math where you don't actually have to show your work. It's kind of crazy. You don't have to show the minus 50, because ultimately we just want to see what we get to. So what we did is we subtracted. Okay, this is where it starts to get a little tricky. All of a sudden 4, I'm talking about DBE. Sure, that's fine. When I get to step 5, I'm talking about angle ABC. Whoa, whoa, whoa. That's not okay. There's no way I can jump from DBE to ABC. Because I look up here, there's no relationship between DBE and ABC at all. So where did they get this? So what I'm going to do is I'm going to look over here at my reason. They use the transitive property. Now, if you remember, the transitive property is kind of like the train. If you have two ends, they're all equal to each other. So this is the middle equals the end, the two ends equal each other. Well, let's see if we can figure this out. If we look at the picture, we realize that ABC is equal to CBD. This is equal to this. Well, we know this is 50. So of course this is 50. If these are equal, and that's a number, that's also a number. So the measure of angle ABC is 50 degrees. That's a transitive property because I use this statement up here and this one as well. This is my front is equal to the middle is equal to the end. So I basically cross these middle guys out and I know the front of the train is equal to the back of the train. Now that was a weird one because it wasn't connected to step 4. So this is probably the hardest part about proofs is when you have a statement that actually is connected to something much higher. And the reason I put it down here at 5 is just because I wanted to use it to get to 6. So eventually you'll get to the point where you'll know where things should go just based on practice. But I could have really put 5 as my step 2 and moved everything down 1 because again, it depended on statement 1. Okay, let's finish this thing off. How do we get from ABC equals 50 to ABC is congruent to DBE? Well, a lot of people at this stage say, well, that's what I'm trying to prove, so I'm going to write prove or done or, yeah, I got this, no problem, right? Well, no, we have to figure out how step 5 got me to step 6. So let's look up here. Oh, I see my answer right here. ABC and DBE are right here. Well, if they're both equal to 50 degrees, then they're equal to each other. Well, that's the transitive property again, because I have something equals 50, this equals 50, so these obviously, we don't need the 50s anymore, they just equal each other. So we're skipping that middle section, and it's end to end. So that's one more thing you should know about proofs, is that you can have a reason stated multiple times in a row. There's no rule that you can only have each property once or anything like that, really. Okay, so we tried some of those properties, but we didn't get to all of them. So I wanted to show you instances of the other ones. So let's say this is my proof. I have my statements over here and my reasons over here. If my statement 1 says x equals y, and then my statement 2 says y equals x, what should my reason be? Pause the video if you need a second, look back at your notes, and figure out what did I just demonstrate here. Well, I demonstrated the symmetric property. Here we go. Right? All I did is I changed the order, first to last and last to first. And again, it was just easy as that. Because it went from step 1 to step 2, the reason went on step 2. All right, you're probably looking ahead at this one. If anywhere in a proof, anywhere, it doesn't matter what step it's at, if I have something equals itself, that's just the reflexive property. Again, the more practice we get with proofs, the better you'll see why we would actually use this. Right now, it might seem kind of pointless, but it actually comes into play a lot when you get to triangles. And finally, the third instance, if I have a step here and then this one, what happened? What's the difference between step 1 and step 2? Well, I distributed the 2 around the parentheses, so I used the distributive property. Okay, so I think I got them all in. So let's see if we can complete the success criteria. So again, pause the video. take a couple moments and see if you can fill out the statements. Hopefully that doesn't go so poorly, but then remember the reasons and think about the rules that I instigated. Okay, I'm going to go through this fast because you should just be checking your work. So what I did first is I distributed. I distributed the 2 in, and then I combined these guys, so I just simplified that side. And then I added 14 to both sides, and I divided by 6, so I got x equals 3. So now, let's fill out the reasons. Well, I started with my given. Next, I had to get rid of the parentheses, so I used the distributed property. This step is kind of weird. We actually haven't talked about it yet. I took -10, I did -4, and I got the -14. I wouldn't really call this like adding or subtracting because I'm not actually adding or subtracting something to either side. I like to call it that I'm just simplifying. I'm making my life a little bit easier. Or you could say like combine like terms, like I'm combining the constants. And then what I did is I added 14 to both sides, so I did the addition property, and then they told us already what we should do is divide. Now yours might not look exactly like this, but that's totally fine. An alternative option would be to add 4 to both sides right away. So your second reason would be addition, and then you would have distribution. And then actually, if you did that, you wouldn't have to do the simplify or combine like terms at all. You would eventually have to do addition again to bring the 10 over. So you can have different variations of the same proof as long as you get to the same end result. All right, so when you come to class tomorrow, you're going to do some homework in the books. And yeah, I hope this video lesson went well for you, and we'll see you tomorrow.